Hello, everyone, and welcome to yet another Friday afternoon webinar, jointly organized by NAIL and NORA. And it's a pleasure to have these joint webinars. Together, we reach out to the whole Norwegian community, at least the academic community, but also the industry community, startup community, and so on. So we cover most of Norway. And also internationally, we typically at these webinars have a lot of international participants, both from Asia, Europe, South America, not to mention, and so on. So it's a pleasure to welcome you all today as well. This is not the last webinar. We have one more webinar coming up. Next Friday, June 18th, is a NORA Startup and NAIL webinar, which means it will be focusing on startup. And next week, it will be student startup collaborations, accelerating innovation within AI. And this is, of course, an excellent way to collaborate within artificial intelligence, students and startups together. With that, I will leave it to Trym to introduce today's speaker.
Thank you, Klaus. The speaker today is Krisztian Balog. Krisztian is a professor at the University of Stavanger, leading the Information Access and Artificial Intelligence Research Group. He is an adjunct professor in AI and NLP at NTNU, and he is also a former staff visiting faculty researcher at Google. His general research interests lie in the use and development of information retrieval, NLP, and machine learning techniques for intelligent information access tasks. He has an impressive age index of 40. He has published over 175 papers, including an open access book on entity-oriented search. He serves as senior program committee member at several conferences. He is a former associate editor of ACM Transactions on Information Systems and the coordinator of several information retrieval benchmarking efforts. He serves as the general co-chair of ECIR 22 to be held in Stavanger, Norway. And he is also the recipient of the 2018 Karen Spark Jones Award and a member of the Norwegian Academy of Technological Sciences. So, Krisztian, with that impressive CV, I'm looking forward to hear from you today. The title of his talk today is Towards More Natural Interactions with Conversational Recommender Systems. So, Krisztian, please.
Thank you very much for the kind introduction. I just want to check if you can hear me.
We can hear you and we can see your slide.
And you can see my slides. Yes, so greetings from Stavanger. The weather is actually better than what my background picture suggests. And some of you might have heard me speak at one of these series about a related topic, and I try to change the contents of this talk so that there is some overlap with the previous presentation, but not that much. And before I start, I want to just acknowledge my co-workers, who include colleagues at Google, as well as my former PhD student, Shuo Chang. So I want to talk about recommender systems in this presentation. And let's start by just giving you some general setting. And I think you are all familiar with the traditional recommender systems. Netflix, YouTube, Spotify all work in similar ways based on the user's interactions with the different items. The system presents a set of recommendations. And typically, these recommendations are organized according to different shelves, and these shelves have labels, and those labels might be seen as explanations for the recommendations. And the user can interact with these recommendations, give ratings or thumbs up, thumbs down. And based on that feedback, the next time they visit the site or when they refresh the page, they are presented with a new set of recommendations. Now, I want to contrast this with a conversational recommender system, which would work as follows. we can assume a chat-based interface where this conversational agent would ask the user, what sort of movies are you interested in? I like thrillers a lot. Thrillers, for example, Zodiac is one of my favorite movies. Okay, what do you like about that movie? And then the user might start sharing, saying, well, I just think serial killers are in general are interesting. So the movie was really good. And it went really in depth, and it was a long movie, but still it made him feel that he was part of the world and blah, blah, blah. Okay, so based on that, the system might say, oh, have you heard about Deadpool? It's a movie about an ex-special forces guy, and it's a comics book movie with some inventive storytelling. And then the user might say, yeah, I don't really like comic book movies that much, but that recommendation sounds interesting, so I might be willing to watch that. All right. So more formally, a conversation recommender system is a software system that supports its users in achieving recommendation-related goals through a multi-turn dialogue. And there are some fundamental characteristics that differentiate it from other types of systems. One is this multi-turn conversational interaction. It's a specific task-oriented dialogue system. Part of the task is to understand the user's preferences and personalize the recommendations, as well as provide an explanation for the recommendations in natural language, not just a simple label on a shelf. There are some challenges in this space, and I categorize them in two main categories. One comes from the natural language nature of the interactions. How can we understand user preferences? How can we provide explanations? And the other one has to do with evaluation. So far, we still have a limited understanding of what makes it a good dialogue experience, what makes it enjoyable. And there's a shortage of appropriate evaluation mechanisms. So I will talk about these things. It's also interesting, this topic, because it's an intersection of different research areas. And this is an extremely complex and multifaceted problem. And these different research areas focus on different aspects. And there are many similarities and differences, which make it a unique problem. And in this talk, I will indeed combine techniques from information retrieval, from recommender systems, and from dialogue systems. And I didn't mention natural language processing and machine learning because that's everywhere. That's present in all these three fields. Okay, so more specifically, I will talk about three aspects of what it means to be more natural for a conversational recommender system. The first one will be about explaining preferences and recommendations. The second one will be about interpreting feedback or critiques in natural language. And the third topic will have to do with evaluation. Throughout the talk, I will be using movies as a use case because most people like movies. It's very easy to relate to, but I want to emphasize that the techniques are not specific to movies. They should be applicable to any domain. Some of this talk might be technical, and I know that it is a Friday afternoon, so you might decide to leave somewhere halfway, and then I don't want anyone to go empty-handed. So I just want to give the main take-home message early on. It's critical to have appropriate evaluation methodology and resources to make progress in this area. So that's the summary of this talk. And I will be covering 3 parts based on recent work. I will stop after each part to see if there are any questions, and I'm very happy to take questions along the way to make it a bit more interactive. This first part is based on work that I did with colleagues at Google, and it's about explaining preferences and recommendations. I want to motivate it with the same classic recommendation scenario that I already mentioned in the opening. So we have this setting where users watch items, give ratings to those items, and then there is some recommendation model. These days it is often a neural model that generates a list of recommendations. The difficulty or issue with this approach is that if our preferences change, let's say someone is no longer engaged in a romantic relationship and no longer needs to pretend that they like romantic movies, then it's very difficult to tell this system not to recommend any romantic movies anymore. Because the only thing that the user could do is to go back to the history and either remove or downrate all those movies that are influencing the recommendations that they don't want to see anymore. Instead, what we would prefer is if the user model was transparent and explainable. For example, it would be a set of statements about preferences of the user, and then the user could scrutinize this summary. So tell the system that, no, I'm no longer interested in romantic comedies, and the recommendations would immediately be affected. So this is the main research question that I'm asking in this part. How can we explain user preferences and recommendations? The approach will consist of 3 main steps. One is how to model user preferences, then how to explain those using natural language, and then how to make recommendations based on this user model. One of the simplest things that we can do is to model a user's preferences as a weighted set of tags. So think of movie tags. That would be thrillers and romantic comedy and so on. The problem with that is that it alone is not that expressive to capture realistic user interests. If you remember the example that I showed about the user who didn't like comic movies in general, but there were some exceptions. So we can capture this by considering how 2 sets of items might interact. And in this example, we can see that there's a user who doesn't like science fiction movies in general, but likes movies about space exploration. And that is a set interaction that can be turned into a natural language summary. And we can think of several of those pairwise set interactions. You like one movie, one set, one tag, especially if the second, or you don't like it, especially if the second, and so on. So we can generate a model, and such model is shown in the table on this slide. So we have either tags or pairwise tags and some weight. That's great. The only thing here is that this model might be too large. So we need to subselect a part of these tags and show that concise summary to the user. And we can rank them based on utility, which is basically we greedily score these tags based on how significant they are, how many items they cover, and how well, and what is their weight. And then we rank them and select the top K ones. Next, we can turn these into textual statements. These interactions are designed in a way that by simply instantiating a template, we can give a summary of that tag or pairwise tag interactions. And what we do is we additionally add an example to ground that statement. It's much easier for users to understand what we mean by that if there is a specific example. In this work, we only use 2 grades of intensity. So you either like or don't like something, but one can easily think of having several grades or intensity of likes and dislikes, and use a bit more varied language around that. Now, we have this user model, and we have this natural language summary of the user model. All that is left is to develop a recommendation model. And we design a very simple content-based approach that compares the tags that are in the user model against the tags that are associated with the item. We call it a set-based model. It's really a very simple model. We can combine it with the item popularity, which is a way of relying on collaborative information. The more people generally like the movie, that can be incorporated as a prior. And then one nice property of this model is that any recommendation translates directly to a subset of the user model. We can subselect statements from the user model that contain the tags, and that is an explanation why that item is recommended to the user. Okay, so we would like to evaluate that, and for that we do a user study. Why do we need a user study and not just use an existing benchmark? Primarily because existing benchmarks are highly biased. They only contain ratings for items that users have seen. And if we have a model that recommends items that users were never exposed to, according to the benchmark, they would be considered non-relevant suggestions, while in real life, they might be relevant. So we have this user study that consists of 3 steps. First, we ask users to rate some movies on a 3-point scale. And additionally, we also ask them to tell us what they liked and disliked about the movie. We don't really use that information. We just want to make sure that they actually spend some time on thinking about whether they really liked or disliked that item. Then, based on those preferences, we generate a summary of the user's preferences, natural language summaries, and we ask them to give us feedback on that. Since we are doing this with over 100 users, we want to make sure that this feedback is actionable, so we can automatically process that. And for that reason, it's set up as follows. We give users a complete statement and then remove parts of that segment progressively. And we ask them to select the best one from top to bottom that applies to them. And then we can update the user model accordingly. And then in the last step, we generate a set of recommendations using both baseline methods and our set-based model, and we want to compare the results. Okay, so first we look at some of the baseline methods. And one thing to notice here is that the simplest possible baseline, just recommending items based on popularity, performs best. And it performs best on this user study in this more realistic setting than more advanced methods that were reported to perform better according to benchmarks. Then we compare it to 2 versions of the set-based model. One that we call fully transparent model is where the recommendations are based only on 5 statements and only on the tags that are in those 5 statements. Or we can also use the whole user model, but only show the summary of the top preferences. And that's what we call partial transparency. And we see that it performs better than the baselines. And using this item popularity prior helps. And that holds for other evaluation measures as well. So the main takeaway message here is that it is actually possible to make a recommender system explainable and transparent, and one doesn't have to sacrifice effectiveness for that. There are several avenues for future work. These explanations are template-based, and they can be made more human-like by using a model for generating the explanations. This model can be generalized to explain not only item preferences, but arbitrary interests in a personal knowledge graph. And there are better ways to utilize feedback that users give on these summaries. So this is the end of the first part. I can stop here for a few seconds to see if anyone has any questions.
Do we have any questions from the audience? Let me see.
There was someone raising hand.
Yeah, I think we have Muhammad raising his hand.
There you go. Now you should be able to talk, Mohammed. Unmute. Yeah, there you go.
Can you hear me now?
Yes.
Yes, we can.
Yes, can.
Yes, you can hear me. Yes. Thank you, Krisztian. So I worked with Krisztian at NTNU, so I know him. So it's about intent detection, right? Intent detection from the user side. So you have a kind of a set of intent on the content side, and then there you have intent on user sides, and you just have to match these two, isn't it?
I wouldn't use the word intent, because that usually means something else. I mean, the intent is to get recommendations for movies that I would be interested in watching. What we are operating with is preferences. So what kind of movies do you like?
It's kind of building a user profile.
Yes.
Yes. Yeah, thank you.
Okay.
More questions? You can either write in the Q&A or you can raise your hand. It doesn't look like it, Krisztian, so I suggest we move on, and then we'll also have a Q&A towards the end.
All right. Then I move on to the second part, which is about natural language critiques. And this is, again, another work with Google. And this is to appear in July, actually. So you get to hear about it before it's actually presented at the conference. I'm still within the same movie recommendation setting, conversational system. And now we want to understand critiques, so feedback on recommendations. And you can imagine that a system recommends some movie, and then the user gives a feedback about some aspect of the movie. And that is what we call a soft attribute. So a soft attribute is a property that is not something that is universally agreed upon, but where it's meaningful to compare two items and say one has more of an attribute than the other. So one movie is more violent than the other, or one recipe is more complex than another. And you might think at this point that this resembles tags, and that is true, but there are two crucial differences. One is that tags are binary labels, whether the item has that property or not, and they don't allow for this partial ordering. And the other one is that most platforms where users provide tags bias users towards using a consistent vocabulary by presenting suggestions, and just even just by showing what other users attached as tags to that item. And that is very important because it has implications for evaluation, and I will come back to that. So the question is, how can we interpret and measure these nuanced natural language critiques that I will call soft attributes? And I will focus on two things here, how to develop a test collection for this task, and how to develop what would be effective methods for the task of soft attribute-based critiquing. And the task is ranking items relative to a given anchor item with respect to a given soft attribute. So let's say the system recommended a movie, Inception, and I want something that has less of a plot twist. Then I want to be able to rank other movies with respect to that soft attribute. So generally for this task, the process of creating the test collection would go as follows. We need to sample some soft attributes, then we need to get some ground truth item orderings, and we need an evaluation measure that tells us how well an item ranking agrees with the ground truth. And I will present two collections. One is based on tags in a tag it's called the Movie Lens movie collection that is publicly available, and the other one is one that we are developing, or we developed based on a conversational data set. Both are based on some popular movies in a collection. Let's start with the tag-based collection. You can see some examples of tags which may be regarded as soft attributes, and we can infer ground truth using a heuristic that we can say there is one set of items where this that did not get this tag assigned by any user, and we have another set of items where a significant portion of users who assigned any tag to the item assigned the given tag. So we have these two sets, and then we can measure ranking by looking at pairs of items in the ranking and checking how well they agree with the ground truth. Are they ordered concordant or discordant with the ground truth ordering? Alternatively, and this is the main contribution of this work, we can sample, we can build soft attributes based on an actual conversational data set. And you can see an example of some exchanges between a user and an assistant in a collection where they talk about movies. And from this collection, we extract soft attributes where the user said, I want more of that or less of that, or that movie is just too blank for me. So too intense, too violent, and so on. Already at this point, we noticed that about half of these were never used as tags. So these are different, even on the surface level. Then we design a multi-step crowdsourcing interface to collect pairwise item orderings. And what we want is to, in a way, force users to think about how items compare according to a given soft attribute. But we want to collect a large number of these preferences. So just showing two items, that would take a lot of work. Instead, we first ask users to tell us which movies from a pool they have seen. And then for each soft attribute, we give them an interface that is depicted on this slide. So there is a set containing usually 10 movies, and there is an anchor item. And there is a soft attribute, let's say that's violent, and they have to drag and drop these items into 3 categories based on whether they are less violent, about as violent, or more violent than the anchor item. And the number of preferences we can collect this way depends on also on how we feed this interface, how we select the items. And I don't want to go into the details there. I just want to show the top illustration where there is on the left, all items are in the leftmost bucket, and on the right, items are more uniformly distributed across these buckets. And that's what's desirable, because then we can infer more pairwise comparisons of preferences. So there is a certain methodology that helps us to achieve that. Now, since we have these 3 buckets, we can have a stronger metric, and it's an extension of the previous evaluation metric, but it differentiates between more and less and much more, much less. So the first part is the original version of the metric, where we just look at the number of concordant and discordant pairs in adjacent buckets. And the second part, which we assign double weight to, looks at the leftmost and rightmost buckets. And if those are swapped, that's a bigger mistake. Okay, so then the question is, how can we apply these critiques in a recommendation setting? And the core idea is that if we can generate a ranking of items according to a soft attribute, then it's enough to find the reference item that is marked with orange in that ranking, and then we know which direction we need to move to if the user wants more or less of A, which is the soft attribute. So our objective is to devise a scoring function that can be applied to any item and soft attribute pair. I will just very quickly go through it. The main idea is to represent both items and soft attributes in some latent embedding space. And we can learn representations for soft attributes in this embedding space in 3 different ways, from no supervision to full supervision. The first one, the unsupervised way, is to build on term-based retrieval models from entity retrieval. We have a review corpus, and then based on that review corpus, we can rank items, and we can represent a soft attribute as a centroid of the item embeddings in a space. And then we can score items based on their distance to this soft attribute in that space. We can take this idea a bit further, because the unsupervised model only uses the top ranked items, so only positive examples in a way. We can also use the bottom of the ranking and say that those are negative examples, and then use these as pseudo training examples. So assuming that the top ranked ones would be positive examples and bottom ones would be negative examples, we can learn a regression model and then score items based on that. Or if we have this preference data that is collected using this interface that I presented earlier, we can also develop a fully supervised model that would learn pairwise item orderings. So I want to walk through the evaluation results. In this table, we have 2 columns. One is the movie lens, that's the tag-based collection with the original correlation metric. And the other one is a soft attributes collection with the extended version of this correlation metric. In both cases, 1 would mean perfect correlation, and -1 would be the opposite. So higher is better, and 1 would be a perfect score. And what we find is that using this term-based unsupervised model, we get very good results on the tag-based collections, and we get much worse results on the new collection. Then we have another unsupervised method, and performance drops in both cases, so that's okay. Then we have this weakly supervised method, which we would expect that would work better, since there is there's more signals and it's a more advanced model. But what we find is that for the tag-based collection, it performs much worse, whereas for the new collection, it behaves as expected. And if we have a fully supervised model, which is only possible on the new collection because it requires these pairwise preferences, then we would get even further improvements. So the key takeaway here is that using a wrong collection for a task would give completely misleading results. And we need to look at a more accurate abstraction of this attribute ranking problem, which is, first of all, a much harder problem, as we can see from the absolute numbers. But then this new collection enables us to make progress. There's one more interesting aspect that I would like to highlight, and that is that these soft attributes are inherently subjective. So people disagree on what is a boring movie, or what is juvenile humor. Well, maybe that's not that subjective. So in this table, we divided performance into 3 buckets, which were the highest, the mid and lowest performing attributes. And what we find is that the models perform best where there is a high inter-user agreement, so there is less subjectivity, and performance is much lower where there is subjectivity. What it means is that for some of the attributes where there is high agreement, that's the leftmost bucket, we don't need to do any personalization, and that's fine. For the softer attributes, there is significant headroom for improvement, and the models I presented, they were not personalized. So we can see that those numbers are quite low. So I will stop here again to see if there are any questions, and not repeat what I just said. It's on this summary slide before moving on to the last part.
Krisztian, we have a question in the chat. It's from Bernd Bremdal, and it's kind of, I think, as he writes here, it kind of touches on the first 2 parts. So maybe it's appropriate to do that now. I'll try to read it. It's long. But he's asking, regarding the first part of the presentation, I acknowledge the fact that there could be radical changes in preferences for movies as you described. But the more common case would be a more gradual migration from one focus to another. In all learning systems, there are always the tension between exploration and the exploitation to determine a change in base recommendations with a decay factor associated with the learning. So here are my 2 questions. 1, could this not be used as a contextual basis for the NLP to hone in, I think it is, on the intentions of the user to reduce the number of interactions? So do that first, and then the second afterwards.
Okay, I'm not sure I understand the question correctly, but I can say something to the intro of the question, and maybe it's not a radical change, but users have, in a traditional setting, the system infers some preferences based on how I interacted with items, and it might just infer the wrong preference, and this is a direct way to correct that. So it might infer that I like that movie because of this or that, but that movie might just be an exception. I actually don't like comic movies. I like this movie because of X. Or I don't want any recommendations that have a certain actor, for example, because I just cannot stand that person. And there is need to correct the system's understanding, irrespective of how gradually my preferences change or not.
Bernd, I opened, if you want to discuss, you can also unmute and take part.
All right, thank you. I acknowledge the fact that there could be some radical change over a short time that needs that type of correction now, but I just wanted to sort of address the fact that there could be a gradual gravitation towards something else that the NLP could actually use as a background piece of background information in order to determine and reduce the number of interactions with the user, that so you contextualize it a lot better.
Yeah, I agree.
All right, that was the short answer.
Very good. How about the second part of the question, Bernd? You can ask it yourself.
Well, yeah, I think you touch upon this in the second part, which actually I find this very interesting. But you said that some of the problems with sorry, there's my phone. Some of the problems that you have with areas or offers that are not explored by a user, where you don't have enough history to actually make any judgment or recommendations. In learning systems, there's always this tension between exploration and exploitation, and couldn't just sort of build some impetus for a user to actually explore more than he does, and then use the NLP part as you described in order to sort of spur that actions. And based on that, you could consider this as a learning system where you cover a lot more of the state space and action space, actions being preferences, state being the different offers, and consequently you could interpolate that and use a regressor in order to determine what would be the axis of potential interest and so forth. And I think you touched upon this basically, or a little bit in your second part, but this was actually my original question.
That's a very good point, and there is certainly room for that exploration and exploitation approach or paradigm here. I think my point is more like, so that's somewhat orthogonal. So we can use that to determine what items we might want to give the users as suggestions. But what we get back in this conversational setting is much more than just like or dislike. The user actually discloses preferences in natural language, and they don't just say, well, I didn't like that movie, but they say, I didn't like it because X, Y, and Z. And that's where NLP comes in, because we want to be able to use that rich feedback to better model the preferences. And it's a very interesting area for future work to see how that could be combined so that the items are selected in a way that we learn the most about the user's preferences.
Yeah, okay, that makes sense to me too. Well, thank you for your answer. It's very interesting.
Thanks, Bernd, and thanks, Krisztian, for the answers. I suggest we do the third part as well, and then we'll come back to questions.
All right, I will try to rush through the third part. I'm switching gears now, so it's a different topic. It's still conversational systems, but it's about evaluation. And this tree that you see here represents all the possible ways that a conversation between a system S and the user U can go. And there are basically two principal ways of evaluation currently. One is to look at a given turn, and this can be performed offline, where for given user utterance, we have a set of possible system responses, and we know which response would be best. The other way would be to look at the whole course of interactions that's a given dialogue, which we can annotate, but it's expensive, it's time consuming, and it's just one branch in this whole space. So the question I'm asking is, can we simulate users for the purpose of evaluation? And what we want to do in this work is to develop a user simulator that would produce responses that a real user would give in a certain dialogue situation. And there is a formal objective. And the point here is that we want to be able to simulate a given user population with respect to a given evaluation metric. And we say that this is realistic simulation or successful if the relative ordering of two systems agrees for the user simulator with the actual population that we want to simulate. So this work is about a simulation framework and some of its components, and there is some work on better user modeling and better dialogue flow modeling in this within this framework. What we use here is a standard task-oriented dialogue system architecture where there is a conversational agent and the simulator has the same components that a task-based dialogue system, so natural language understanding, response generation, and natural language generation. We build on a well-established framework from dialogue systems where basically there is a plan that the simulated user wants to execute. We call it the agenda. And then this agenda changes based on how the system responds. If the system responds to the user utterance in the expected way, then that's an accomplished goal. Then we move on to the next operation in the agenda. And if it's not accomplished, then we need to replan and have some replacement actions. So there are two main components to this approach. One is an interaction model that defines how this agenda should be initialized and how it is updated. We compare two models. One is a baseline model, which has only 4 states. The user can query or request, and the agent can feedback or accept. Alternatively, we develop an action space that is specific to this conversational item recommendation scenario. And we have a specific flow. Certain transitions are allowed and certain transitions are not allowed according to this model. The other main component is the preference model. So how do we model the preferences of users? In both cases, we ground it in actual data. What it means is that we use this movie lens collection, which contains items and user ratings on items. And we use one part of it as a preference profile and the other part as a test data. So imagine that we sample some users, and then the activities of that user to some point in time, until some point in time, are used as preferences, and the rest are used for testing. In the baseline case, we only consider if the user has seen or not that item. And for the preference, we just flip a coin. And of course, that will offer limited consistency because the user might like or dislike combination of items which are not very realistic. A more advanced approach is to assume that we have item ratings available, and then we model the preferences in a personal knowledge graph where we have 2 types of nodes, items and attributes. And whenever a new preference is disclosed, that's added to this personal knowledge graph, and that way we make sure that whatever the user says is consistent with the preferences that are already captured there. For evaluation, we compare 3 existing movie recommender systems, A, B, and C, using both real users and simulated users. For the real users, we set up a crowdsourcing task where they are asked to interact with an agent until they get a recommendation for a movie that they like. And for the simulated users, we train some of the parameters of the model based on the behavior of real users. So we ask a number of questions here. One is, how well do the relative ordering of systems correlate when using real users versus simulated users? In this table, the first row corresponds to real users, and the following 3 rows correspond to different configurations of the simulator, going from the simplest to the most advanced one. And we basically find that in all but one case, the simulated users agree with the real users. In actually the best performing model, which is highlighted, flips the ordering of systems A and B according to success rate. And that's because it tends to terminate earlier than actual users do. But this is not that big, not an unreasonable error, because those 2 systems are very close in terms of success rate. So the absolute values are quite close. Overall, we see that there is a very high correlation between automatic and human evaluations. To understand how realistic these simulations are, we design an experiment which may be seen as a reverse Turing test. It's set up as follows. Users get the transcripts of 2 conversations in random order, and one conversation is made by a real human, and the other conversation is made by a simulated user, and they have to guess which one was the simulated user. In a way, in this experiment, we are trying to fool the human evaluators. So the more often we can do that, the better, the more realistic the simulator is. So again, we have the 3 systems as columns, as well as the aggregated results, and we have the 3 versions of the simulator. And we find that the best simulator could fool users or human evaluators in 36% of the cases. It lost in 41% of the cases, and in 23% of the cases, it was just not possible for the human evaluator to tell. So we attribute these improvements to personal knowledge graphs and to better preference modeling, both of which are shown to improve. So that is the summary of this part. I presented this general framework and talked a little bit about this interaction and preference models. This is not the end of this work. We have some ongoing work where we are trying to make simulators more human-like, and I just want to spend my last minute on that. And one of the traits of being more human-like is not giving up immediately if the system doesn't understand us. So imagine an exchange where the user would want to know more about restaurants in Dubai, and the system completely misunderstands it. Now, this is the part where the existing simulator would break down, and it would be a complete agenda update. So it would try something different, not ask about restaurants or restart the conversation. Instead, what a human might do is to ask, well, slightly differently, can you find me a restaurant in Dubai? And then the system still doesn't understand. Can you rephrase? And then a human would just say, places for dinner. And this is a real human behavior that we observed by conducting a user study and studying how users reformulate utterances. And one common pattern we observed is that first they would try to repeat, like the agent didn't understand it in the first place, and then try to slightly rephrase it, and then they try to drastically simplify. And we can simulate this behavior using transformer-based language modeling techniques. And there is a lot more directions that one can think of to make simulation more realistic, considering the persona, how preferences change over time, considering not just text, but also speech, multimodality, images, clicking, considering how users learn and forget, and how users learn what limitations of the system are and how they can work around that. We have a workshop at SIGIR that I just want to quickly plug in here. If you are interested in simulation, then that's going to be a great event. And my slides are now telling me that I need to stop. So I will just stop with this summary slide and leave it up there and take some questions if there are any.
Very good. Thanks a lot for a great speech, Krisztian. Let's see if there are any questions. We have one here from Susanna saying, how was the user study conducted? Were the users more eager to rewrite the sentences because it was part of a study?
Yes, users were instructed specifically to be persistent and not give up, and try to make as many attempts as they can. So this, in a way, is the super persistent user. And when we want to plug this behavior into the simulator, then user persistence would be a parameter that we can adjust. And less persistent users would be willing to maybe try once, and others can try several times.
Yeah, makes sense. We also have Adam raising his hand. I'll open you can unmute now, Adam, and ask your question.
Yes, thank you. Can you hear me?
Yes, we can.
Yeah, thank you for the nice presentation. My question is from an information security perspective, is that do you think that these conversational recommender systems are more vulnerable or have different vulnerabilities than more traditional systems, and that if they are more transparent, then is it something that intelligent adversaries can exploit? For example, if I have a movie and I'd like to get it recommended to everyone, I might come up with some specific tricks.
Yeah, that's a great question, and I don't have a very good answer to that. We have done some work on or there's some work in the literature on explanations and what purpose they might serve. But if someone is trying to make a very persuasive explanation just to make as many users watch a movie as possible, and even tailor this explanation so that it appeals to the user and relates to their personal preferences, it's possible. But I don't think it's any more, it's similar to Netflix trying to recommend the same movie to you and putting something on the top of your recommendations every time. Recommender systems can do that.
Great, thanks. I think we are at the top of the hour, actually. And I have no more questions from the Q&A or chat. So I think it's it's time to wrap it up. Thanks again, Krisztian, for a very, very interesting talk. And wish well, thank you for coming here, and thanking everyone in the audience also for showing up for this late afternoon presentation. So thanks everyone, and have a nice weekend. Cheers.
Cheers. Bye.